Bismillahirrahmanirrahim. In this video, we are going to look at recursion, particularly recursion when we talk about C++ functions. So what is recursion? Recursion basically means that the recursive function is calling itself. So what are recursive functions? Are functions that call themselves, and they can only solve the base case. So it's a function that's going to keep calling itself, and it will only be able to solve what is known as a base case. We'll see in a moment what this base case is and why do they call themselves. This function, why it's calling itself, and what is a base case. But for now, we know that recursive functions are functions that call themselves. They can only solve what is known as a base case, and if it is not a base case, then it will call itself, but it will call a smaller problem. So for instance, I'll give you an example. The example is, suppose I want to solve 5 factorial. So I have this notation 5 factorial. So a factorial basically is the multiplication of all numbers less than or equal to 5. So 5 factorial is basically 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So if I want to solve this, but I want to solve it for some generic number n. So let's say I have n factorial. So this is going to be n into n minus 1 into n minus 2 multiplied by so on multiplied by 3 multiplied by 2 multiplied by 1. I want to solve something of this sort. So in this case, instead of solving for n, if I am given to solve n factorial, I will divide it into 2 problems, and I will say that solve for n minus 1, and then I will say solve for n minus 2, and so on. And that is why these functions are recursive in nature. In the next slide, I will show you a detailed example of why these are recursive, and why do they call themselves, and how do they divide the problem into smaller problems. So the function launches a new copy of itself. So a new copy, when we say a new copy, it means that it is a new instance of the function. What it means is that the new function that is being called from the original function will have a new set of variables, parameters, everything. So it's like an entirely different function. The original function and the function being called, they are they will be treated as 2 different functions. There is a new copy of itself, and the trick here is that the original function is trying to solve a more complex problem, and it will divide the problem into smaller sub-problems, and then the new copy of the function will try to deal with the smaller problem, and it's going to keep doing recursively until it goes to what is known as the base case. The base case is basically the simplest case. So the simplest case for which we know the solution. So it is such a case for which we know the solution. So for instance, in the case of factorial, we know by definition 0 factorial is 1, and 1 factorial is also 1. So this in our case will be the base case. So if I need to calculate 5 factorial, I need to do this computation. However, 0 factorial and 1 factorial by their definition are 1. So this is a base case. It means that if I am given find the factorial of 0, I don't need to compute anything. I just know that the answer is 1, because that's their definition. That's the simplest case. And so the original function that is being called will do 2 things. First of all, it will launch a copy of itself with a smaller problem to work on, and makes a call to itself inside the return statement. It means that the smaller function being called by the function with the more complex problem the smaller function, when it finishes computation, it will return the result to the original function that was calling it. So let's look at it, and eventually the base case will be reached and all the values will be computed and they will solve the whole problem. So this is how it looks like. If I have something like, let's do that 5 factorial again. So 5 factorial is actually 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Alternately, this here is 4 factorial. So basically I can write 5 factorial is equal to 5 multiplied by 4 factorial. Now perhaps you are getting where we are going with this. This is a problem. It's a more complex problem because it's asking you to find the factorial of 5. You have divided this into two parts. The first one is simply do 5 multiplied by, and the second part is compute the factorial of 4. Now this, you don't know the answer of that, you have to compute it. However, this is a smaller problem as compared to computing the factorial of 5. So computing the factorial of 4 is a smaller problem than this. If my function was, for instance, I want to write int, and let's call it fact, and int, let's call that n, because I want to compute for n factorial. So somehow in here I will have 5 multiplied by, so this function I'm going to repeat that, but instead of passing 5 I'm going to actually pass 4, or rather n minus 1. So there is something to be done here. It's not finished, it's not the complete code. We'll see what needs to be here. And here I have main and int n is equal to 5, cout factorial of n. So as you can see here, the value being passed over here is 5. So the value being received in this n will be 5, and this is basically 5 into, here I am passing n minus 1. It means that in the when the main function calls the function factorial, a copy of the factorial will be created in the memory. So this is factorial. Here the value of n is 5. When this calls factorial itself, it means a new function space is created. Again it is factorial, but in this case it is 4. Why? Because I am passing n minus 1. So when this function is called, it's again this function, this complete function, ये पूरा function call होगा. इस केस में जो वैल्यू आई थी यहाँ से वो 4 आई थी, और ये जब क्रिएट करेगा अपना फंक्शन अगला, उसमें एक और कॉपी होगी जो कि बेसिकली जिसमें n जो है वो n माइनस 1, तो n 4 आया था, इसने कॉल किया तो 3 क्रिएट होगी. ये अगेन एक क्रिएट करेगा एक और कॉपी जिसमें n इज इक्वल टू 2 होगा, और सो ऑन, ये चलता रहेगा. अच्छा, हम चाह ये रहे हैं कि जी यहाँ तक जाए, और क्योंकि हमने लास्ट स्लाइड में कहा था, यहाँ पे भी लिखा हुआ है कि 1 फैक्टोरियल एंड 0 फैक्टोरियल इज इक्वल टू 1. सो वी वांट दिस 5 टू बी डिवाइडेड इनटू 5 इंटू 4 फैक्टोरियल, एंड देन ये जो 4 है, दिस पार्ट, दिस इज गोइंग टू बी सॉल्व्ड बाय 4 मल्टीप्लाइड बाय 3 फैक्टोरियल, and this part is going to be solved by 3 multiplied by 2 factorial, and this part is going to say 2 into 1 factorial, and this will be the base case. We know the answer of 1 factorial is 1. So ओरिजिनल जो फैक्टोरियल जो कॉल हुआ फंक्शन, वो उसमें 5 कॉल हुआ. इसने बेसिकली, अगर मैं फैक्ट को f लिख दूं तो इसने f of 4 फैक्टोरियल कॉल किया, इसने f of 3 फैक्टोरियल कॉल किया एंड सो ऑन। ये यहाँ तक आएगा और आखिर में जब 1 फैक्टोरियल आएगा उसका आंसर हम उसको डायरेक्ट दे दिया करेंगे और ये जो है ये इसको रिटर्न करेगा। 1 फैक्टोरियल इज 1, तो 2 इंटू 1 2, तो यहाँ पे आंसर जो रिटर्न होगा 2। ये 3 इंटू 2 क्या होगा 6, तो यहाँ पे आंसर जो रिटर्न होगा इसको वो 6 होगा और 4 इंटू 6 जो है वो इसको 24 आंसर रिटर्न होगा और ये जो आंसर इसको रिटर्न करेगा वापस जहाँ से मेन से कॉल किया था वो 120 करेगा 5 इंटू 24। दिस इज हाउ इट वर्क्स। सो लेट्स ट्राई टू, ये हमने अभी एक बेसिक इसकी वर्किंग देखी है। लेट्स सी हाउ इट actually works in C++. So here I will create again the function, but this time we'll try to fill it together. So int factorial and इसमें आपके पास आया int n. So the function starts here and the function ends here, and here I have my int main, int n is equal to 5 and cout factorial of n, and here I'm going to write return 0. So this is the same code as in the previous slide. However, let's write what the function needs to do. So what we need to do is the original function being called from main, this is factorial of 5. I am going to substitute the value n. So this is basically the function being called is factorial of 5. Now what we want this function to do is return, क्योंकि इसने कॉल किया है इंटीजर टाइप, इसकी रिटर्न टाइप है, तो इसने वापस मेन को कुछ रिटर्न करना होगा। वी वांट इट टू रिटर्न 5 मल्टीप्लाइड बाई 4 फैक्टोरियल। नाउ दिस 4 फैक्टोरियल विल बी एक्चुअली रिप्रेजेंटेड बाय दिस इज इक्वल टू रिटर्न 5 इन C++ कोड, क्योंकि उसमें तो इस तरह नहीं होता, मल्टीप्लाइड बाई फैक्टोरियल ऑफ 4 which is basically 5 minus 1, ये चीज आ जाएगी। और ये जो है इसको फिर इसने कॉल किया आगे, ये जो 4 फैक्टोरियल है ये होगा 4 इंटू फैक्टोरियल ऑफ 3 and this should call 3 into factorial of 2 and this should called 2 into factorial of 1. Now here we need to stop because 1, as we discussed, 0 and 1 are basic cases. So इसको कोड करने का तरीका यह है कि I will write the base case. I will say if n is equal to 0 or n is equal to 1, then the answer of 0 factorial and 1 factorial is return 1, because we know the answer is that. So this is going to return the value 1. Return the value to what? To whom? किसको रिटर्न करना है 1? मेन को नहीं करना, जिसने इसको कॉल किया है उसको करना है। मेन को सिर्फ करेगा अगर ये n जो है ये 0 या 1 होता। इसने कॉल किया था, डायरेक्ट कंडीशन चेक होगी और ये फंक्शन 1 होगा, मेन को रिटर्न कर देगा। ओनली द केस वेयर n इज इक्वल टू 0 और 1। अदरवाइज इन दिस केस n इक्वल टू 5, तो फैक्टोरियल ऑफ 5 जब हुआ था तो फैक्टोरियल ऑफ 5 ने कहा था रिटर्न 5 इंटू 4 फैक्टोरियल। 4 फैक्टोरियल जो था इसने कॉल किया था 3 वाले को, 3 वाले ने कॉल किया था 2 को, 2 ने कॉल किया था 1 को। सो जब यहाँ पे वो वाला कॉल होगा, जब n1 आएगा यहाँ पे, ये वाला फैक्टोरियल कॉल होगा फंक्शन जिसमें आर्गुमेंट या वेरिएबल 1 आ रहा होगा, इसने किसको रिटर्न करना है? जिसने इसको कॉल किया था। इसको किसने कॉल किया था? फैक्टोरियल ऑफ 2 ने इसको कॉल किया था। इसका मतलब है ये इसको रिटर्न करेगा वैल्यू। सो फैक्टोरियल ऑफ 1, सॉरी यहाँ पे फैक्टोरियल ऑफ 1 इसने ये कॉल करेगा, यहाँ पे डायरेक्टली 1 वैल्यू जो है वो रिटर्न हो जाएगी इसको। ये है 2 इंटू 1 फैक्टोरियल 2, ये वैल्यू किसको रिटर्न होगी? 2 फैक्टोरियल जिसने कॉल किया था। यहाँ पे वैल्यू 2 आ जाएगी। सो 3 इंटू 2, this is 6. This will be returned to the function that called factorial of 2, which was this 4 into 3 factorial. तो fact of 3 जो है उसने इसको कॉल किया था। इसने आगे जो है वो रिटर्न किया 6, और 6 इंटू 4 जो है ये रिटर्न होगा यहाँ पे इस वैल्यू पे 24, और 5 इंटू 4 इसको किसने कॉल किया था? इसको कॉल किया था मेन ने क्योंकि n 5 से कॉल किया था तो यहाँ से ये कॉल हुआ था। इसने आगे इसको कॉल किया, इसने आगे इसको कॉल किया, इस तरह जाता रहेगा तो रिटर्न भी उसी तरह ही होगा जिस सीक्वेंस में गए थे। सो फैक्ट ऑफ 5, फैक्ट ऑफ let me write it. Main was the calling function. Main called fact of 5. Fact of 5 called fact of 4. Fact of 4 called fact of 3. Fact of 3 called fact of 2, and fact of 2 called fact of 1. Fact of 1 was calculated as 1. This will be returned to this. The value being returned is 1. इसने फिर आगे मल्टीप्लाई करके जो है 3 इंटू करके इसको रिटर्न किया। ये जो रिटर्न वैल्यू होगी 3 फैक्टोरियल, ये होगी 6 यहाँ पे, क्योंकि 3 इंटू 2 फैक्टोरियल था। तो इसने इसको रिटर्न किया 6, इसने इसको रिटर्न किया 24, इसने इसको रिटर्न किया सॉरी यहाँ से रिटर्न किया 1 इसको। दिस वाज 3 वाज 2 इंटू 1 फैक्टोरियल, सो इसने रिटर्न किया वैल्यू 2, दिस इज 2. This value being returned here is 6, this value returned is 24, and this value returned here is 120. So जिस सीक्वेंस में ये कॉल हुए थे उससे ऑपोजिट सीक्वेंस में ये रिटर्न होंगे। सो अगर तो n 0 या 1 है तो आपने 1 रिटर्न कर दिया, ये स्टॉपिंग क्राइटेरिया है। वरना मेन ने 5 को कॉल किया, 5 ने 4, 4 ने 3, 3 to 2, 2 ने 1, आगे हम नहीं जाते 1 0 को कॉल करे, 0 -1 -1 -2 को कॉल करे, नहीं, हम एक स्टॉपिंग क्राइटेरिया जाते हैं, यहाँ पे जाके रुक जाए। तो स्टॉप ओवर हियर, दिस इज द स्टॉपिंग क्राइटेरिया, एंड द स्टॉपिंग क्राइटेरिया इज ऑल्सो कॉल्ड द बेस क्राइटेरिया, एंड इट इज द केस वेयर वी नो द आंसर डायरेक्टली, वी डोंट हैव टू कंप्यूट. Other than that, if it is 0 and 1, return this, else return n multiplied by, जो हम बराबर कर रहे हैं 5 में आया था तो 5 into 4 फैक्टोरियल था, else return n into factorial of n minus 1, 5 into 4, तो 4 into 3, so अगर ये n है तो ये n minus 1. This is the logic. So here we can have if it is true, do this, otherwise return n into factorial of n minus 1. So ये इसी तरह चलेगा, मेन 5 से कॉल करेगा, 5 जो है वो क्या करेगा, 5 into 4 फैक्टोरियल को कॉल करेगा, 4 जो है वो 4 into 3 फैक्टोरियल को, 3 जो है वो 3 into 2 फैक्टोरियल को, और इस तरह ये जाएंगे, और 1 पे जो है वो यहाँ पे रुक जाएगा, यहाँ पे डायरेक्ट रिटर्न आ जाएगा, रिटर्न 1, और ये वाला जो रिटर्न 1 है इसमें कोई रिकर्सिव कॉल नहीं हो रही है. दिस इज अ रिकर्सिव कॉल. व्हाई? बिकॉज द फंक्शन इज कॉलिंग द फंक्शन अगेन. दिस इज अ रिकर्सिव कॉल. This is the base case or the stopping criteria, because here you are returning a constant value, you're not making a function call. So this is the base case and this is the recursive case. There are two cases. This one here is the base case and this one here is the recursive case. So that is how factorial works. So basically the idea of the factorial is that you will have a problem, you will divide it into sub problems, and then you will solve each of the sub problem until you reach the base case, and at the base case you will start replying to the cases that were calling it until you are able to solve the entire problem. So here is how it looks like. I wrote n is equal to 0 or n equal to 1. You can replace is at n is less than equal to 1. So 0 और 1 वाले दोनों cases यहाँ पे आ जाते हैं. Otherwise return n into factorial of n minus 1. It is interesting to see that both the number over here and the return type is unsigned long. Long is the largest integer you have, and unsigned उसमें भी plus minus को हटा के. Factorial can never be negative. ठीक है? So you don't need the sign. If you remember, we said that you can write minus 128 to 127 as a values, or if you forget the minus, then it will going to be from 0 to 255. So you're basically increasing the range that you have. Same goes over here. Long में जब आप unsigned करते हैं तो उसके effectively इसका size double हो जाता है. And why you are using long? It's because the values of the factorial grows very quickly. So it is one of those cases जहाँ पे 5 factorial is 120, then 6 factorial आप करें तो 6 into 120 ये आपके पास जाएगा, फिर 7 करें, 8 करें, तो बहुत तेजी से ये ग्रो करता है. So you need a large enough integer that will hold its value. Int I think stops at unsigned int stops at 65,000. So you are going to very quickly reach that value 65,000. Maybe 10-15 factorial भी नहीं आप calculate कर सकेंगे इस पे. So you need a long return type so that you can hold the large values that will be returned using the factorial. So this is the code for the factorial. The three important things that needs to be taken care of whenever you are writing a recursive function. The first one, there has to be the पहले आपने start जो करना है कोई भी recursive function बनाने के लिए, the first thing you have to do is write the base case. Base case जब आएगा if condition में उसकी क्या value होगी जो return करेगी. If you don't write this, it means that your program is never going to stop. It's going to run infinitely. So the first thing you need to do is, you need to remember, is that you have to write the base case. Second thing that you need to do is, how do you divide the problem into smaller problems? So in this case, यहाँ पे आपके पास बहुत simple था. 5 factorial is equal to 5 into 4 factorial. So just एक step में divide हो गया. This step can be more complicated. It can be a set of 2 steps. It can be 3 steps. और ये else लगाना है कि नहीं लगाना, जो चीज़ रिटर्न के बाद आप लिखेंगे वो कब एग्जीक्यूट होगी, रिटर्न से पहले लिखेंगे वो कब एग्जीक्यूट होगी. क्योंकि रिटर्न का तो मतलब यह है कि इस फंक्शन से आप वापस जा रहे हैं, तो इससे आगे की जो चीज़ है वो तो आपने प्रिंट ही नहीं करनी है फिर. So it's important to know that the keyword return means you are returning from the function. So anything that is returned after that won't be executed. And what is returned before will always be executed unless कि कोई इसमें other कोई logical या कोई crash हो जाए इस function. So it's interesting to note that the same thing, the thing we did using this recursive function over here, this recursive function, if n is less than equal to 1, return 1, else return n into factorial of n minus 1. ये काम जो है वो आप लूप से अगर करना चाहते हैं तो आप लूप इस तरह से कर सकते थे. For int I equal to n minus 1, I is greater than 0, I minus minus. तो बेसिकली जो नंबर है उससे लेके 0 तक आप आ रहे हैं, सॉरी 1 तक आ रहे हैं, not 0. That's why you don't have equal to over here. Otherwise anything multiplied by 0 will be 0. So n equal to n into I. So if n is 5, अगर आपके पास n is equal to 5, सो आपका i क्या है? सबसे पहले जो है n-1, सो योर i इज 4. सो n इज इक्वल टू n, इट इज 5 मल्टीप्लाइड बाई 4. ये क्या चीज़ आती है? 20. उसके बाद i क्या होगा? i जो है वो n-1, इट बिकम्स 3. n इज इक्वल टू n इंटू i. n में क्या है इस वक्त? 20 आ चुका है, मल्टीप्लाइड बाई 3 विच इज इक्वल टू 60. अब n में 60 आ चुका है. उसके बाद i जो है वो 2 पे होगा, i-1 होगा, i माइनस होगा, ग्रेटर देन 0 है, यस, 2 पे होगा. n इक्वल टू n माइनस i, 60 मल्टीप्लाइड बाई 2 विच इज 120. i will become 1, i minus, i is greater than 0, yes, n into n minus i, this is going to be this is 1 multiplied by 1 is the same as 120. I becomes 0. This condition is false. You exit from the loop and return n. n क्या return होगा? 120. So you either do using the loop or you do using the recursion. Perhaps because we are all familiar with the loop, this looks much easier. However, in a lot of cases, this won't be a possible solution and you will have to use a recursion. This is particularly useful when you are drawing trees. किसी चीज़ को आपने ट्री करना है, यानी ब्रांचेस आपने करनी है कि जी ये ओरिजिनल होगा, यहाँ से जाएगा, इस तरह करके जाएगा, एंड यू विल सी सम ऑफ दैट इन योर नेक्स्ट कोर्स जो CS 102 आपके पास आएगा, उसमें ये चीज़ें आएंगी, ट्रीज बनाने, ग्राफ्स बनाने आपने. In that case, recursion is very important. For simpler cases such as the factorial, perhaps you can even use a loop and it's fine, and it even looks simpler than the recursion, because recursion gets some used to okay, what is being called, who is calling, what is being returned. So it's, you know, it needs some time to get used to it, what is calling what. But we'll stop over here for this lecture. In the interactive session, if we have time, if we have questions, we'll answer the questions, and if we have time, we'll look at another example, and that example is of the Fibonacci series. We'll look into that.